Welcome to Module 13, Image Coding Part 2. So in this module, we will address image format, both lossless and lossy, including their characteristics, compression techniques, and some practical applications. So basically the formats that we are going to see are based on the compression techniques that we have seen in previous modules. The first format that we are going to address is the PNG format, Portable Network Graphics, which is very popular and is widely used as lossless format. The characteristic is that the color can be up to 32-bit and in RGB color space. RGB color space is the only color space that is considered in this format. It also allows the transparencies as it implements the alpha channel with 8 or 16 bits, enabling from 256 to 65,000 and more transparency levels. The compression technique that is considered is Huffman coding, and additionally PNG implements the gamma correction, allowing for better color consistency across devices. Gamma correction, in fact, makes possible to correct, at least partially, the differences with which computers interpret the color values. Sometimes computers, other devices and softwares, they interpret the color in different ways. So gamma correction is a technique that is able to standardize and correct those differences. And then the second format we are going through is the GIF format, graphics interchange format, which is also quite popular. It enables only 8-bit for the colors, so we will have just 256 color possible. So due to its characteristic, GIF are not very effective in coding real pictures. In fact, it is much popular for simple graphic, logos or similar. It exploits the LZW algorithm for data compression that we went through in previous module. Transparency is also enabled, but not via the alpha channel, but via the chroma key. The chroma key is a method to assign a color that will be interpreted as transparent by the decoder. So in this case, only one color can be considered for the transparency, and only one level of transparency is considered. It can store sequences of images, assigning time delay up to 1/100 seconds per frame. And this allows the GIF to be very good for animation as well. The next format is the TIFF format, Tag Image File format. And it is very versatile since it supports different color spaces. Indeed, colors are implemented up to 24 bits in various color space, like RGB, CMYK, and others. Can be also extendable in terms of color space to adapt. As for the compression technique, it uses multiple algorithms, including LZW and even lossy JPEG if needed. In the TIFF format, data are organized as a sequence of bytes, indexed by a complex hierarchical table that is devoted to take track on how to aggregate them. This structure enables easy extendability. Here, you can see a couple of very simple examples of the data organization. So let's take, as the first example, an 8-bit grayscale image. Each byte represents basically a pixel. So now if we move to a 24-bit RGB image, we can have, for instance, one organization devoted to have 3 consecutive bytes RGB to represent 1 pixel. By changing the organization of the indexing table, bytes can be mapped on pixel on different way. So you can understand that this organization allows the format to be highly malleable and easy to extend. You just need to update the table. In this slide, you can see the comparison between a raw image, that is the original, not compressed image, and the TIFF image. We can notice that the only difference concerns basically the colors. This is mainly due to the chosen color space. Changing the color space also will change the difference between the raw image. Here, you can see the difference between a lossy and a lossless compression. You can notice that the latter presents some degradation of the image quality. Indeed, the lossless formats such as PNG, GIF, and TIFF retain the original image data, ensuring the perfect reconstruction. Instead, lossy formats like JPEG discard non-essential data to achieve higher compression ratio at the cost of some quality. So now let's move to lossy format, and specifically the JPEG format, Joint Photographic Experts Group. It has been created in 1992 and was designed to become a standard for photographic images. It has some characteristics that makes it particularly suitable for several applications. Among them, we can mention the high compression ratio with an acceptable quality up to 10/1, which is a lot. Customizable trade-offs where the user can balance compression and quality. This led the user to be free to choose. JPEG compression follows a strict decoding standard. However, it does not specifically design how to implement compression. This allows companies to develop different JPEG encoder and decoders. So now let's move to the encoding processing of JPEG. Specifically, JPEG compression involves 4 steps. The first is the conversion from RGB color space to another color space, which is called YCBCR, that lose some information. And we will go through all these steps. The second step is the discrete cosine transform. Third is the quantization, where we lose information. The fourth step and the last, data are coded. And here we can choose from a plenty of data coding algorithms that we have seen before, like entropy coding or other techniques. So now, the JPEG allows the conversion between RGB and a space, again, called YCBCR. The color space separates the brightness information Y from the color information CB and CR, which aligns well with the human eye's differing sensitivities to luminance and chroma, thereby allowing for more efficient compression without a significant loss in image quality. This conversion is done by means of the following formula that you can see here. And here you can see an example of the YCBCR space where 3 separate channels are exposed. The second step in the JPEG compression procedure is the discrete cosine transformation, which converts spatial data into frequency data, leveraging our reduced sensitivity to high frequencies. This allows us to manage frequencies separately in the next steps. In this figure, you can see an example of a generated frequency space obtained by the application of a DCT transform to an image. And now let's move to the third step, the quantization. A perceptual model based on human psychovisual system discards high-frequency information, which is sharp transition in intensity and color hue, since we are less sensitive to them. Quantization is a method to discard in the DCT space a certain number of high-frequency coefficients, which contribute less to the overall picture than other coefficients. JPEG permits user to control over compression ratio, and this is proportional to the number of high-frequency coefficient to discard. This allows the user to trade off between the picture quality for smaller file size. Remaining DCT coefficients are then stored. The remaining coefficients are then encoded using RLE or Huffman code. So now let's conclude. And in this module, we explored advanced image formats like PNG, GIF, TIFF, and JPEG, along with their compression techniques. Understanding these formats helps us choose the best one for specific applications, balancing quality, storage, and efficiency. Thank you for your attention.